Every second, a modern industrial facility generates thousands of signals. Temperature, pressure, and energy draw pour out in an unrelenting stream of physical telemetry. Yet, if you ask for a single, straightforward answer for a routine compliance report, extracting that data suddenly requires 2 days, 3 engineers, and a brittle spreadsheet to resolve. Regulated plants are feeling this operational friction acutely right now. Pressures are compounding from NERC CPIP 015-2, tightening EPA emissions protocols, ISO 5001 energy standards, and heightened FDA Part 11 scrutiny. Despite their differences, every one of these regulations shares a common symptom: a rigid, rapidly approaching deadline that demands highly specific historical metrics from your operation. The required data almost certainly already exists. It sits exactly where it has always been captured, trapped deep inside your facility's existing SCADA, DCS, and historian systems. This diagram illustrates the primary bottleneck. It shows a dense, sprawling structure representing a standard historian database. Over years of operation, this environment naturally expands into a massive, undocumented architecture containing hundreds of thousands of individual tags. When a new regulatory requirement arrives, an engineer must open this historian to extract the requested metric. They are immediately met with visual and cognitive overwhelm, looking at a structure containing hundreds of thousands of completely separate signals. The specific signals the regulator requires are buried somewhere in that structure, but they are entirely disconnected from the plain English legal text of the mandate. The law requires continuous emissions data, but the system only speaks in obscure, raw addresses. All the while, the clock on the compliance window is ticking down, while the engineering team attempts to blindly navigate this mass of nodes to find authoritative matches. Industrial compliance ultimately relies on bridging the semantic gap, the distance between the plain English text of a mandate and the specific historian tag addresses required to satisfy it. When a mandate like the expanded network monitoring requirements of NERC CIP 015-2 lands on a plant manager's desk, the immediate operational reaction is usually a defensive reflex. Looking at this architectural diagram, you see a visual representation of a standard false assumption that a new mandate automatically necessitates purchasing new physical instrumentation or building an entirely separate data silo. That instinct is usually wrong. A modern regulated plant operates on a reliable rule. If an industrial process is running, it is already being measured somewhere. The sensors exist. The physical infrastructure is in place. In most cases, the exact signal required by the mandate has been continuously captured by the historian for years. The only missing element is the logic connecting them. You need a reliable map linking the specific legal requirements of the regulation to the exact telemetry data addresses already sitting in your system. Failing to construct that map carries severe business consequences. Systemic failures under NERC CIP can trigger civil penalties reaching into 7 figures per day, and poorly documented FDA records can cause auditors to immediately pause entire production lines. Solving this mapping gap is a critical business continuity imperative. Executed correctly, it eliminates the need to spend capital on massive, redundant data infrastructure. Consider how this friction plays out during a standard EPA emissions review. A facility must suddenly provide continuous NOx and CO2 emissions data specifically for a process labeled Line 3. Step 1 begins when a compliance officer receives the rigid regulatory text and passes it down to a plant engineer without any system-level context attached. This brings us to the traditional workflow, mapped here on the left. The engineer opens the historian and manually searches for the required data points, exploring individual tag paths one by one. They spend days sifting through a 340,000 tag structure, trying to isolate a handful of nodes that might represent Line 3's output. Even when they locate potential candidates, they face immediate uncertainty. Without proper context, there is no way to verify which of the similarly named tags is the authoritative calibrated source. For Step 3, the engineer attempts to resolve the ambiguity by cross-referencing candidate tags against physical instrumentation documentation, which is frequently outdated or missing entirely. This often leads to desperate escalations, requiring the team to track down the original system integrators who wired the plant, many of whom may no longer even work for the organization. In Step 4, an authoritative tag is finally agreed upon, and the data is manually extracted into a spreadsheet to satisfy the current reporting period. Then, Step 5 arrives. The next reporting quarter begins, and this entire fragile, labor-intensive process must be repeated from scratch. Relying on manual data forensics means extracting a single compliance metric requires a highly inefficient, unscalable drain on your critical engineering talent. There is a logical architectural replacement for this manual workflow: agentic tag mapping. It removes the burden of the search by closing the semantic gap directly. Look at the right side of our workflow diagram to see the agentic integration model. A system like Valak AI connects to the existing historian using an air-gapped, read-only OPC-UA architecture. This ensures zero risk or impact to your control systems. Once connected, the AI natively browses and learns the complete OPC-UA tag tree structure on its own, mapping relationships automatically without requiring human guidance. This setup replaces weeks of forensic hunting with a direct plain English interaction. An engineer simply types a query into the system. Which tags on line 3 capture knocks at 1-minute intervals? The AI instantly translates that semantic request into operational logic. It navigates the tree, illuminates the correct authoritative branches, and returns the tag descriptions alongside their current historical values. Identifying the tag is only the first step. The system then executes a critical secondary function: automated data validation. It checks the historical data generated by that tag against the regulator's strict structural rules, proving automatically that the required 1-minute interval density is actively being maintained. Once verified, the platform initiates continuous, lossless archiving of those specific tags, establishing a permanent, locked record from that moment forward. By translating plain English directly into database architecture, agentic AI condenses a multi-week physical investigation into a conversation that takes seconds. Securing data retrieval at this speed alters your strategic timeline. Standards like the expanded NERC CIP 0152 typically provide an 18-month regulatory runway before strict enforcement begins. This chart illustrates the concept of a compliance baseline. Look at the x-axis, mapping that 18-month timeline. Waiting until month 12 to manually hunt for data leaves you with a brief, volatile window for an auditor to evaluate. By mapping the tags and initiating automated capture on day 1, you build an unbroken baseline of data integrity. When the auditor finally arrives, you walk into the room holding years of verified, defensible evidence. Once that pipeline is established, compliance reporting ceases to be an ongoing operational burden. The extraction is continuous, and the requirement is officially a solved problem. Solving the audit yields a significant secondary advantage. This pristine, isolated compliance dataset is now fully queryable in plain English by anyone in your organization. Plant engineers can take the exact same regulatory data extracted for the EPA and repurpose it for high-level operational intelligence. Instead of simply filing a report, an engineer can query the average line 3 NOx emissions and correlate those variations with specific raw material lots to actively optimize batch yields. The physical signals already exist inside your facility. The compliance deadline is fixed. Agentic AI provides the semantic link between the two, transforming a mandatory regulatory burden into a persistent data asset that pays for itself through continuous process optimization.